right, so the first thing I would do is make sure that I have plenty of highlighters. If you don't have one, I would go up and get one. Shout out to those that get them on a regular basis, and shout out to those that actually use them. So in number 2, a square has sides that are each 90 feet long. Which equations can be used to calculate d, the length of the diagonal? Notice that select all that apply, so that means you have more than one answer. Okay? So the actual question part is which equations can be used to calculate d, which is going to be the length of a diagonal. First thing I would do is sketch a square. Okay? And we know that squares have right angles. And you will be calculating the diagonal of all those right angles. So there is your diagonal. So what I'm going to do is there are 2 ways. Well, first I actually should label all of my 90 because the sides are also 90. Okay, so there is there's actually going to be 3 answers to this. There's going to be 2 using trig, so we can go through and I will do the trig ones. Trig is SOHCAHTOA, so sine, cosine, or tangent. If I pull out one of these triangles, so if I pull out this whole triangle right here, the diagonals bisect the end angles, which means we end up getting a special right triangle because half of 90 makes 45. So these guys are going to be 45 degrees. Okay, we know that's the side of the square, so that is 90. And that's another side of the square, and there is your right angle. So we could see that if we wanted to find the diagonal, which is this guy, so hopefully you can kind of see that that diagonal is the hypotenuse, we could do, let's use this angle. You could be using opposite over hypotenuse to find that side length, so that would be sine of 45 equals 90 over d, because d is the diagonal. And also keep in mind that we don't have to solve it. You could also then use, to find that missing side length, you could be using cosine of 45 degrees equals 90 over d. Okay, so that would be finding the missing side. That's, I believe, the 3rd flap on your foldable. So I would maybe circle or X, however you want to do it. But those 2 are definitely ones that represent the side length. And then you can also do this using Pythagorean theorem. Okay, it is a right triangle. So Pythagorean theorem is the 1st flap on your foldable. So again, if you just pulled the triangle out, okay, you have 90, so you would be finding the hypotenuse of the triangle, so you would have to do 90 squared plus 90 squared equals b squared, because those are the sides, so we have an A and we have a B. Okay? If we wanted to solve, I'm sorry, I shouldn't have put b squared. I should have put d squared, because that represents the diagonal. Okay? And then if we want to just solve for d, we would end up square rooting both sides. So d is going to equal the square root of 90 squared plus 90 squared. And that is B. Okay? So in order to get the full points for number 1, I will need to see your sketch. I need to see both the sine and the cosine work, so a sketch for that, and then a sketch for Pythagorean theorem. So this problem is worth 4 points. on the Miss Bailey scale. Okay? All right, moving on to number 28. So the figure shows triangle ABC. Which of the values are equal to the sine of B? So the first thing I would maybe remember is that the sine of B is going to be the opposite side over the hypotenuse. So that is going to be, obviously, B over C. So that's one answer, but if you pay close attention, it is also asking for, oh dear, I just found the wrong sign. So sine is opposite over hypotenuse, so it's going to be B over A. Please, super duper, make sure you get that corrected. Okay? Then we also want to look for values that are also going to give us the same value of B over A. So if we're looking at angle C, the function that would give us B over A would also be cosine. So the cosine of angle C would also be B over A because that's adjacent over hypotenuse. So the cosine of C. Okay? And then a couple weird ones that are park related. So angle B can also be represented as 90 minus C. So you could be taking, instead of the sine of angle B, you could be taking the sine of 90 minus C. And then angle C can be represented as 90 minus B. So you could also choose the cosine of the angle 90 minus B. Okay, so this would be a 4-point problem, so I would give you a point for identifying that sine is opposite over hypotenuse and getting that first one right, and then getting basically the other three right. So you would have to have some pictures that shows that you marked those angles as 90 minus their values, because if you didn't, I don't know how you would have assumed it since we haven't done that in class. So that is also a 4.1 on the Miss Bailey scale. So if you followed along with this whole video right now, you should have 8 points. Okay? All right, number 29, I will probably be setting up for you and you will have to solve. So a carpenter is constructing a triangular roof for a storage shed as shown in the figure. How high will the peak of the roof rise above the shed? Give your answer to the nearest foot. Okay? So the peak of the roof is going to be, we're going to be calculating that distance. So I will be pulling a right triangle out. Okay? And through the magic of math, this peak comes down right in the middle of the 45. So that makes this guy 22.5. The angle as 15 degrees. And we will be finding that side. So, in reference to what we have, let me switch back to pen. We have an O and an A, which means we're going to be using tangent. So, tangent of 15 equals x over 22.5. Okay, and I will leave you to solve that on your own. So you will get a point for setting it up and a point for getting that right answer. Okay? All right, so then after the roof is constructed, it's going to be covered in asphalt. The carpenter needs to calculate the combined length of the two sloping sides. So that is a sloping side, and that is a sloping side. What is the total length needed of the roof covering? Round to the nearest foot. So what I'm going to do is I'm going to show you how to calculate one of the sides, bringing this out again. Okay, and then you have to keep in mind that there's going to be two of them. So in this case, we're going to be calculating the hypotenuse. So we have adjacent over hypotenuse, which is going to be cosine of 15 equals 22.5 over x. So you're going to get an x, but you need to remember that there are two x's. So once you get your x, you can either multiply it by 2 or add it to itself. And then you need to round your answers to the nearest foot. So you will get 1 point for setting up the correct proportion, 1 point for getting the correct x, and then 1 point for getting the correct complete answer. Okay, and you'll have to solve those on your own. So this whole problem is 5 points on the Miss Bailey scale. All right, moving on to number 4. In number 4, you have right triangle WXY is similar to triangle DEF. The following are measurements in the right triangle. So I will let you know that I have redrawn the triangle. The Park only gave you these. I have provided you a sketch. Okay? So since the triangles are similar, if it wants you to find the cosine of W, that's going to mean whatever W corresponds to is the same. So if you find the cosine of D, you actually also find the cosine of W. Okay? And I will let you know, for some reason, you do not need to rationalize the denominator here. Okay? And to rationalize the denominator. Okay? So again, all you're going to do is look at angle D now, and if you find the cosine, which is adjacent, and put it over the hypotenuse, you found the cosine of W. So this should be a super duper easy problem for you. I will probably give you a point if you actually wrote down that it's going to be the same as cosine of D, and then I will give you a point for the right answer. So this is a 2-point problem. Okay? Since I just went over number 4, I am going to make number 7 completely on your own. Use the reasoning from number 4 to help you. And this is also going to be a 2-point problem. I will give you a point if you tell me what the tangent of H is the same as. Okay? All right, flip over. So number 12, you have Mary Alice standing in a building and looking out the window of a tree. So you can see that she looks out upwards at a 42-degree angle and she looks downwards at 31 degrees, which that's what they go over. So we want to know the height of the tree. I'm going to use 2 different highlighters, and we're going to find the top half of the tree, which is going to be represented by this side, and the bottom half of the tree is going to be represented by this side. So altogether, yellow plus red equal the tree. So again, what I've done is I've brought out those triangles and labeled it for you. You would have to kind of do that on your own. But I think if you start with one of these triangles, so start with 42, we're finding side lengths, so that is the second flap on your paper. And you can see that this is O, and that's A.
May I have your attention for one announcement?
So the tangent of 42 degrees equals x over 20. And you'll have to get your x. Then if you came over here and did the 31 degrees, you can see that this is an O and that's an A. So you are also using tangent of, this time 31 degrees equals x over 20. And you're going to get an x. Okay? So what I would do is I will give you a point for the correct setup and the correct x in each scenario. And then I will give you a point if you actually go and add those x's to get your final answer. So this is a 5-point problem on the Miss Bailey scale. Okay? All right. Number 17. So in number 17, you have the ocean floor and the ocean surface. You have a ship and a probe. The probe's traveling 3,900 meters at an angle of depression. So they've diagrammed that for you. The question asks, how many meters below the surface of the ocean will the probe be when it reaches the floor? So I want to make a note that you're finding this distance, and the 3,900 goes on that hypotenuse. So I've brought that triangle out for you, and that is the distance that you're drawing, or you're finding, because that's where the probe is, and the ship is up here, and the probe is going to be coming from the ship at a diagonal. So that's why the hypotenuse is the 3,900. So you're finding that guy, which, if you have your angle, that's O and H, my favorite, sine. So I'm going to be checking your setup, and then you should be getting an X, and please make sure you have a label on it. Okay, so you will get a point for the correct setup and a correct X, which makes this one a 2-pointer on the Miss Bailey scale. Okay? All right, 23. 23, I'm going to completely let you do on your own. I'm going to go through and highlight the sides I want you to find. It's a little weird, so I want to make sure that you know what you're actually finding. So 23, part A, you are finding what is the distance in meters from UAV to the fire. So that is this hypotenuse here, because the UAV is up here and the fire is down here. And then in part B, you are finding the length of AD, and the UAV is right here, and again the fire is right there.